So, fundamental theorem of algebra. We don't really make a big deal of this, as we should probably. But whatever the highest power is tells you how many answers there are. X squared means there's 2 answers. X cubed means there's 3 answers. We have a quadratic formula, so we can always find those 2 solutions. There is a cubic formula. It's really complicated and it's multi-step, but you can always find those 3 solutions. Anything more than that, it's a whole lot more work to figure out what those solutions are. But x to the 4th is going to have 4 answers. And x to the 6th, even x to the 6th equals 1, has 6 solutions, which seems a little bit weird. You probably know some of the answers. What to the 6th would equal 1? 6 to the 6th? I don't know what 6 to the 6th is. That's not 1. So what to the 6th power would give me 1? 1 to the 6th would give me 1. 1 times 1 times 1 times 1 times 1 times 1. Anything else multiplied by itself 6 times? Negative 1. But there's supposed to be 4 others. 4 others? I'm not going to say imaginary. I'm going to say complex. So they include an imaginary part. So there are 6 answers. Today we're going to figure out how to get all of the answers rather than just kind of the easy ones. Okay, that box doesn't do much for us, so just skip over that. Writing the complex number in trig form helps us find all the roots. So when we write them in trig form, it's, I shouldn't say easy, easier to find those missing roots. So let's think about the complex number negative 16. Say negative 16. But that's the same thing as negative 16 plus 0i. And then if we graph that, like where is that? It's over there. That'd be the same thing as 16 cis I. And now let's find the 4th roots of this complex number. So it's like we have x to the 4th equals negative 16. And that is not negative 2 or 2, right? There's something else going on. There's something complex going on. Okay, here's how we do roots. It's really similar to how we did powers yesterday. I'm just going to undo them. So we can do 16 to the 1/4. With the angle, let's see, well, we do the same thing we did yesterday. Yesterday we multiplied the angle by the power. Today we're going to multiply the angle by the power. So pi over 4. And let's see, 16 to the 1/4 is 2. So 2 cis pi over 4. That's one of the answers. In fact, let's graph that one. 2 cis pi over 4. So we can rotate pi over 4 and go out 2. We can also write it in standard form rather than trig form, but I think trig form is easier. Like we can convert it if we want to. I think it's going to be easier to visualize what's going on if we keep it in trig form. So we'll rotate to pi over 4, and wherever 2 is, we'll go out 2, and so there's our first answer. To x to the 4th equals negative 16, one of our answers is 2 cis pi over 4. I don't know, maybe that feels weird. Let's go ahead and convert it to a plus bi form as well. It kind of depends on the application which one's easier to deal with. So let's just get both. So cosine pi over 4 is root 2 over 2. Sine pi over 4 is root 2 over 2. So root 2 plus root 2i. those are the same thing, right? 2 cis pi over 4 or root 2 comma root 2. They land us at the same spot. Okay, that's called the principal root. It's the first one that we find. But there's 3 more. So here's the deal with finding the first one, hold on, before we talk about finding the rest of them. Finding the first one isn't really too bad. It's the same thing you did yesterday. Put the power on the r and multiply the angle. Exactly what we did yesterday. Now, to get the other roots, the other 3 in this case, are distributed evenly. Like angularly evenly, if that's a word. So they'll be 2 pi over 4 apart from each other. All right, because 2 pi's all the way around. There's 4 roots, so that means they should be pi over 2 away from each other. This might have been easier to just do it on the graph. Like, if there's 4 answers and they're equally spaced, well, one of them would be over here in the second quadrant, over here in the third quadrant, and then in the fourth quadrant. A little bit, yeah. Like you're equally spacing the petals? Yes. Okay, so let's write a generalized way to get those points. The fourth roots of 16 cis pi are, okay, so that was 2 cis, the first one was pi over 4. The second one, like that's the easy one, that's the principal root. That's our name for it. The first one, the easy one, the first one we find. Then we got to equally space them. So pi over 4 plus 2 pi over 4. I'm going to leave it as 2 pi over 4 because 2 pi is all the way around. So plus 2 pi over 4, that's our second one. The next one would be 2 pi over 4, but we're going to go 2 times 2 pi over 4. Obviously that reduces, but that'll get us, so that'd be pi, that would move us to that third one. And then for our last one, pi over 4, plus 2 pi over 4 again, so we're going to add 3 2 pi over 4s. Coming up with the equations is kind of weird. It's almost easier to just know that they're equally spaced. Two pi over n apart. Where n is however many roots you're looking for. N roots. So we're going to turn the page and there's going to be an ugly formula there. I wouldn't worry about the formula. The main part is they're 2 pi over n apart because you want to equally space them. Okay, so there's the ugly looking formula. So you could memorize that. Here's my comment. That's yuck. Okay? Here's my steps. Find the principal root. That's the easy one. That's exactly what we did yesterday. Put the power on the r, multiply the angle. So r to the, or the nth root of r, I guess we could say, and theta over n. That's our principal root. In fact, I should probably just write cis theta over n. That's our principal root. Next, I wouldn't worry about that formula. I would equally space them by 2 pi over n. Again, this is correct. It's just that's a lot to think about, and you certainly wouldn't want to try to memorize all that. Find the principal root, that's easy. And then just think about, well, where are the rest of them so that I equally space them? Let's try a problem. I think these are easier than this formula makes it look. Determine the square roots of 36 cosine pi over 3 plus I sine pi over 3. Write your answer in standard form. Okay, so after we equally space everything, we'll have to put them back in a plus bi form, but we'll worry about that later. So the square roots of 36 cis pi over 3. So 36 cis pi over 3 to the 1/2. The principal root's the first one, the easy one. So that's, some of you would skip what I'm about to show, but that would be the square root of 36 times cis of pi over 3 times 1/2. So my principal root is 6 cis pi over 6. That's the main one, that's the first one. Now the next root is, how far away is the next root in the angle? Okay. Let's see. How many roots do I need? 2. So my next root is going to be 2 pi over 2 away. Maybe a picture would help. 6 cis pi over 6. So that would be shallow angle, 6 out. And if we're going to equally space 2, well, that other one's just going to be opposite over here on the other side, which happens to be pi away. So my other answer would be 6 cis. And I can either add pi, or if I can do it graphically, that's 7 pi over 6. So there's my 2 answers in trig form. In a plus bi form, cosine pi over 6 plus I sine pi over 6. Let's see. I'm trying to do steps in my head here. Cosine pi over 6 is root 3 over 2. So that'd be 3 root 3. Sine pi over 6 is half, so plus 3i. At 7 pi over 6, same process, like we've done this step Monday and Wednesday. We've done this step a lot. Sine 7 pi over 6. So that would just, so actually both of those would just be the negative version of what we just had. So there's my 2 answers in standard form. Okay, big picture, what that means is if I squared either one of these, I would get back to what we started with. I would get 36 cis pi over 3. That's kind of weird to look at, to think you'd square that and get that, but you would. So, when finding all the nth roots of a complex number, write the complex number in trig form so that you've got r cis theta. Determine the nth root of the real number, so that would be the nth root of r. In fact, You know what? I would just say find the principal root first. Cis theta over n. That's your principal root. That's the first one. The easy one. And then the n roots are all 2 pi over n away from each other. Let's just say 2 pi over n apart. So you just keep adding 2 pi over n however many times you need to add it to get however many roots you need. Again, this can lead to a formula, but I don't really want to worry about the formula. I think it's easier to just sort of build up. 2 pi over n is kind of the big deal, because that's how far apart they are. We're good. We're going to skip number 4, but we can do number 2. Determine the fourth roots. So that means it's like we have x to the fourth equals 81 cis 3 pi over 5. Write your answer in reduced trig form. Oh, that's a good one, right? Because that means I don't have to switch it back to, I don't have to do the unit circle stuff. I can leave it in the cis form. So we like this. So I want the fourth root of 81. And then I'll multiply 3 pi over 5. I'm going to divide that by 4. This is a convenient one because 81 has a nice fourth root. Let's see, that'd be 3 cis 3 pi over 20. You don't have to label it your principal root, but that's the first one. That's kind of the easy one.
Is this calculator?
No calculator. So we will give you ones that work. Yeah, I'm not going to ask you for the fourth root of 80 because I don't know what that would be. Well, you just have to leave it as the fourth root of 80. Which I'll come back to that in a minute. Okay, so how far apart? Let's see, I got 4 roots. So how far apart is, or where's the next one? What's the angle away to the next one? I need to go 2 pi over 4, which is pi over 2. So I'm going to add pi over 2 to get my next one and my next one and my next one. Let's see. 3 cis 3 pi over 20 plus pi over 2. That would be, let's see, 10 over 20 and 3 over 20 would be 13 over 20. And then I'm going to add, I guess you could do this sort of, you could add pi over 2 to the one you just got. That might be the easier way to go. Or you can add 2 pi over 2, 2 rotations to the original. Yeah, it might be easier to just take 13 pi over 20 and add pi over 2 to that. So yeah, I'm writing this, but in my mind I'm just going to add 10 over 20 to that. That would get me 23 pi over 20. And now that that's easier, and I've got a pattern going, I'm not even over here anymore. I'm going to add 10 over 20 again and get 33 pi over 20. And if I added it one more time, so if I lost count of how many roots I had, and how many I needed, I would get 43 pi over 20. What's 43 pi over 20 coterminal with? 3 pi over 20. So it would mean I've gone all the way around, and now I'm back to my first one. And we get to leave it in trig form, so yeah, we're good. So find the principal root, figure out how far apart they are, and go from there. I want to change up number 3 at Dia's request. Determine the 6th roots of negative 7.
I didn't say that.
No, but you ask about the calculator, and you don't want to find the 6th root of 7, right?
Now my name's gonna be on
You're going to be famous. So let's do a number that has a nice 6th root. And the easiest one would be 2 to the 6th. That'd be 64. So let's change this problem to negative 64. It'll make our life a little easier. So this is like x to the 6th equals negative 64. So I guess I could take the 6th root of both sides, but that's not really going to help. I want to write that in trig format first. Let's see, negative 64 would be over here. So how can I write that with a cis? What angle would that be? Pi. So I could rewrite that as 64 cis pi. That's the same thing as negative 64. And then I can raise both sides to the 1/6. So 64 to the 1/6 cis pi times 1/6. And since we tweaked this, 64 to the 1/6 is 2. So 2 6 pi cis pi over 6. There's my principal root. That's my first one. It's not my only one because I know there's supposed to be 6 of them. Okay, what do I need to add to the angle to get to the next one? That's the key question. Yeah, I'm going to say 2 pi over 6, which is pi over 3. Now I need to be careful about space only because this wants it in standard form. So that's kind of awful, but that's all right. So my next one would be 2 cis pi over 6 plus pi over 3 would be 1/6 plus 2/6 is 3/6 pi over 2. I'm trying to save space here. Maybe this is not a good idea. It's not showing my work. 2 cis. Here we go. I'll show it over here. Now I'm going to add pi over 3 again to get my next one. So what would that be? 3/6 plus 2/6 is 5/6. And then I'll add pi over 3 again. I'm just going to add pi over 3.
It's just like count the number of jumps on this.
What do you mean? Like, you might be right.
Like you're starting at pi over 6 and then it's going over 3. 3 it's because pi over 3 that means it's like 3 jumps, so then you go 1, 2.
Oh, I see what you mean. Yes.
And then you add the next
Like you're going to do it like sort of graphically, visually. And when you say jumps, you're saying each jump is pi over 6. So you're going to jump pi over 3. So it'd be 2 jumps, right? No, you're right.
No, you start at pi over 6 and then you do 3 jumps, so it's pi over 3. Like
See.
you're traveling pi over 3 each time.
Yes, you're traveling pi over 3 each time. Yes. So the next one, you're absolutely right. So the next one would be over here at 5 pi over 6. And the next one would be 1, 2, 3 would be 5 pi over 4. 5/6 and is that right? I'm doing it mathematically. I'm doing it numerically over here. Dia's doing it graphically. That would be 7 over 6, yes? So not over 4. So be careful counting.
So like if it's
So they're I think you need to ignore the over 4s and make it a 2 jump problem, and then you're on to something. So you're on to something, but be careful doing it that way. 7 pi over 6 plus pi over 3 would be, in fact, 1, 3, 5, 7, 9, and 11. Like you start to pick up on the Whoops, except 9 pi over 6 is 3 pi over 2. So, not wrong, just need to reduce it. So there's my 6 answers. And if I add pi over 3 again, then I'm at 13 pi over 6, but that's the same as pi over 6, and so I've made the full circle. So I guess back to your question. You can do it graphically, but be careful, make sure you're equally, make sure you're jumping the same amount each time. Those are my trig answers. This is yeah, I'm trying to figure out how to shortcut this, but I don't think I can. Let's see, cosine pi over 6 is root 3 over 2. Sine pi over 6 is a half. There's probably going to be another pattern on here somewhere. Maybe not, though. Cosine pi over 2 plus I sine pi over 2. Cosine pi over 2 is 0. Sine of pi over 2 is 1, so 2i.
Wait, why is it 2i?
Because of the 2 up front. 2 cosine 5 pi over 6 is a unit circle. Hope you know your unit circle. I won't call anybody out, but I hope you know your unit circle. Cosine 5 pi over 6 is negative root 3 over 2. So negative root 3. Sine of pi over 6 is a half. So plus I. Cosine 7 pi over 6. Sine of 7 pi over 6. So that's also negative root 3. But sine of 7 pi over 6 is down, so minus I. Three pi over 2, that should be a nice one. Cosine is 0. Sine's negative 1, so minus 2i. And then lastly, cosine 11 pi over 6 plus I sine 11 pi over 6. So that's another root 3. Sine would be negative I. I don't like doing standard form. It's so tedious and you lose sight of, in trig form it's nice because you can easily see, let's see, there was a pi over 6 answer, a pi over 2 answer, 5 pi over 6, 7 pi over 6, 3 pi over 2, and 11 pi over 6. Got this nice little snowflake looking thing there because they're equally spaced. The first one is pi over 6 and the rest were pi over 3 apart. So, kind of crazy that you can solve. We didn't do like a simple one. Yeah, let's stop there. What's that?
I like that one.
You do like it?
I like it.
I don't like it in standard form. I do like it in trig form.
Yeah.
Because it's easy in trig form. Find the first one and then equally space the rest. And then to get to standard form, it's just kind of yuck.
20 times as well.
Oh, one more comment, and then I'll pass the worksheet out. That means, way back at the beginning, we said what number could we raise to the 6th and get negative 64? Let's look and see if I got a calculator up here. That means I should be able to raise any of those to the 6th and get negative 64. Your calculator will do it if you're in the right. Oh, I don't like this one. So I should be able to sixth any of those things and get negative 64. So I'm just going to pick one. Let's do negative square root of 3. I'm checking this one. Minus I, which, where is I? It's in there somewhere. There it is, second I. Oops. So negative root 3 minus I to the 6th. That should be negative 64, and it is. And I should be able to check any of those and get negative 64. So that's kind of neat that it would work out that way. All right, your assignment's worksheet 3, and I'll pass back worksheet 2.